Well, hello guys. This is unusual. I'm actually sitting in the classroom making this video today. So if you hear some noise, it's PE. What I wanted to do is go back and touch on a graphic organizer that we had drawn of a box with 3 concentric circles inside. And that dealt with the idea of what rational numbers are. So what I'm going to do is break it down without the picture of it, and we're going to write out the different parts to the rational numbers. So rational numbers is the overarching label for all the numbers that we've studied, okay? And remember, rational starts with the word ratio, so it's any number that I can rewrite as a ratio, which is a comparison of two numbers using division, or we can also call it a fraction, okay? So first group I want to talk about are the integers, just because they're the most recent. And I'm going to talk about what are the groups inside the integers. So in the integers, we do have 0. Just so you know, that's not the letter O. We have positive natural numbers. So 1, 2, 3, 4, and so on. And then we're also going to have negative, or the opposite. So I'm going to write negative, and then I'm going to write opposite. So it's the opposite of the natural numbers. So if we've got 1, its opposite is -1. That would be what we're kind of talking about as negative natural numbers, okay? So that's what this chapter has been about. Let's go back and visit another chapter, and that would be the one on fractions. So that actually was in chapter 4. Now, fractions, what's going to be unique for us at this point is we can talk about, well, let me try that the other way. Let's go back to what we started with, positive or negative. So any fraction that's positive or negative is considered a rational number. Now, that also includes mixed numbers and improper fractions. They're considered, because we can rewrite them as a fraction, improper fractions. Those all are considered rational numbers. Okay, and then we have another group called decimals, and that was chapter 3, very first one we started with, and we've been practicing a little bit with creating decimals out of fractions in yesterday's practice. Now, these again can be positive or negative. They're all considered rational. Okay, and that includes repeating decimals. Those are the tougher ones because you don't know when you get to stop. Sometimes it may go on for a long time, like when you divide by 7, you get that 6-digit repeater. And then you also have the one you're more familiar with, terminating decimals. So there's no remainder. All of these are considered rational numbers. So some ideas of how we can compare them. So I'm going to put this over here, or put here, to compare. Some ideas to think about. One, you're going to when you compare positive to negative, what we know is that positive is always greater. Okay, that's a no-brainer, right? And then comparing and ordering different numbers, so different types of numbers, So we're talking, you could be comparing an integer to a fraction to a decimal, so on and so forth. You need to first, actually, you know what, I'm going to take that away. I'm going to put that in its own column. Now, for you guys, this is still going to fit on one page in your notes. Just remember, because I'm on landscape, that's where I'm having some issues with mine. So you should still be writing vertically until you get, not even 3/4, probably about 3/4. So when we're comparing, let's say comparing/ordering, different types of numbers. And I think we talked about this before. They need to be all the same. So just like we did in the chapter 2, I can't compare a decimal to a fraction to a percent. I need them all to be percents or all fractions or all decimals. So I'm going to, let's see, comparing right here must be converted to the same type of number. Oops. Of number. So I'm going to give you 2 suggestions, and I'm going to put them in order of what I think is the easiest. Is you're going to first convert all to decimals. I think that's the easiest way to do this. Okay. The second one, I don't think it's as easy. Convert all to fractions. With decimals, you can take anything, you could divide, it's just easier, I think. But you can convert them all to fractions. Okay? And another thing, and we've talked about this guy before as well, is that you can, so you can graph values on a number line. To compare or order. Okay, so the number that would be considered greatest, it's going to be the one that's farthest right. And the number that's going to be considered the least is going to be the one that's farthest left. Okay? So we're going to get into examples in the next screen. So I'm going to go ahead and go. Pause if you need to at any time to copy down the notes. Sorry for the other bletch on the bottom of the left side of my column here. But again, you're just writing straight down. Okay, so let's see what kind of problems we're going to do. First off, we're going to do a little comparing. So fill each circle, and by circle, we're going to draw one, with greater than, less than, or equal to make a true statement. Okay, so these problems are going to be a little bit different than the ones we've already done. Okay, so the first thing we have to check is let me draw my circle a little bit bigger. First thing I need to check is, are the two numbers the same type of numbers? I can't compare a fraction to a decimal. I can't compare whatnot. So that's kind of what we need to do, is make them be the same. Now, this one is real easy. I do have, both are decimals, and one thing I notice is positive is always greater than negative. So one suggestion is to check signs first. Doesn't matter if they're different kinds of numbers. If the signs are different, we already know what the answer is. The positive one has to be greater than the negative one, okay? So 9.7 is greater than negative 10.3. All right, so the next one, we have 5/8, and we want to compare it to 3/5. Okay, so what we have here is a problem because I can't figure out if fractions, the relationship between them. Even graphing might be a little challenging because it's kind of subjective how we draw it on the number line. So what we need to do is to create equivalent fractions. Oh, sorry. Create equivalent fractions for each with a common denominator. So because we're not coming up with a final answer and wanting it to be as low as terms as possible, we're just trying to figure out how to compare these. The easiest way to do this is to multiply one fraction by the other fraction's denominator. So for example, 5/8, I would multiply top and bottom by 5. Why? Because 5 was the denominator on the second fraction. So what am I going to multiply 3/5 by? I'm going to multiply top and bottom by 8 because that's the denominator of the first fraction, okay? So when I do the math, I get 25/40, and I want to compare that to 24/40. Because the denominators match, the only place I'm going to look is in my numerators. So whatever relationship I get between 25 and 24 is going to be the same relationship I get with my original fractions. Well, 25 is greater than 24, so we're going to take that answer up here, and we get 5/8 is greater than 3/5. Okay? One more like this. And we have negative 94/100ths, and we want to compare it to negative 5/6. Okay, bummer, the signs are the same, so that doesn't help. So probably the easiest thing to do is to convert the fraction to a decimal. So I'm going to do that off to the side. Let's do 5 divided by 6. It doesn't go in there, put in that. 6 goes into 58 times, and already I can see there's a difference. So a difference of 2. I'm going to go 2 digits, and 6 goes into 23 times, which is 18 with 2 left over. And then I'm just going to get repeating, okay? So what I have is the negative 94/100ths compared to negative 83/100ths with a repeating bar over 3. So here's where it gets a little tricky. We're both negative, so the larger number actually is farther away from 0. So when we start comparing, we look at place value columns. So negative 9 versus 0.9 versus negative 0.8. So negative 8 is closer to 0 than negative 9, so that's the relationship that ends up that negative 94/100ths is less than negative 5/6. Tricky, I know. Okay, second set, we're going to order from least to greatest. Okay, and let's see what they give us. So we have, greatest. So we have negative 3 1/3. We have 3.3. We have negative 3 3/4. And we have 3.5. Okay. So I'm going to give you a little hint off to the side how I would do this. So I would first group the negatives and put in order. And then I would group the positives. Oops, forgot my S over there. And order. And then that will do it for you. Now, sometimes, like in this first example, we've got fractions and we've got decimals, but here's the interesting thing about this question is that the fractions actually are negative and the decimals are positive. So let's work at it that way. So let's take negative 3 1/3 and let's compare it to negative 3 3/4. And then the other thing we're going to do is take 3.3 and compare it to 3.5. And that's how we're going to get our ordering done. So first problem I see is both of them are negative 3. So what I need to focus on this one on the left is I'm going to compare 1/3 to 3/4. So negative 1/3, negative 3/4. And so I can do one of two things. I can turn them into fractions that have the same denominator, or I can go ahead and do decimals. But I don't want to do that. So I'm just multiply the first fraction on both sides by the denominator of the second fraction, or both halves. And then the second fraction, I'm going to multiply top and bottom by 3, which is the denominator of the other guy. So let's see what we end up with. We get negative 4/12 compared to negative 9/12. Okay, so when we look at these two numbers and we want to compare, we get negative 4 is actually greater than negative 9, because the smaller the negative, the closer to 0 it is. So right now, I can get to my numbers in order. So the first two, let's see, so the very smallest is going to be the one that goes with the negative 3/4. So negative 3 3/4, and then negative 3 1/3. Now going back to the other guy, it's pretty simple. The 3's are the same, so that doesn't help. So I'm looking at the tenths. So we've got 3/10, 5/10. Well, 5/10 is greater than 3/10. So that says that 3.3 comes next, and the greatest number is the 3.5. And there you go. All right, next problem, and last one as a matter of fact. We've got 2.1 repeating, negative 2.1, 2 1/11, and negative 2. Okay, so let's do the negatives. This one's actually not too bad with the negatives this time. So we've got negative 2.1, and we want to compare it to negative 2. So what I'm going to do is give it also a value in the tenths column so I can do the comparison. So it's really, I'm going to compare 1/10 to 0. Okay, now these are both negative, so again, the smaller the number, the closer to 0. So that means this guy is going to be the larger number. The negative 2 is going to be the larger number. So, of those two. So I can already start putting my numbers in order. So I've got negative 2.1 is smaller than negative 2. Then, with the other guys, my positives, they're going to make me work a little bit harder. So I have 2.1 repeating compared to 2 1/11. So what I'm going to need to do is to figure out what 1/11 is. I'm going to do that off to the side. Put in that. We got a 0. Let's put in a 0. So guess what? 11 can't go into 10. So I have to put in a 0, and that allows me to bring another one. That's going to go in 9 times, which is 99, and I get a difference of 1. And then look what happens. Okay? Yeah. 0, and then it's going to be 99, boop, boop, boop. So this is 2.11. I'm going to give it 2 digits there so that I can compare it to these 2 digits, 0, 9. Okay, so just like we did before, whole numbers, same, doesn't help. And then it's right here where you see the difference. 1 is greater than 0 when they're positive, so that's the direction it's going to go. So 2.09 comes next, and, sorry, wrong. I almost did the same thing I've seen people do on the test. 2.09 is really 2 1/11, and then we have 2.11 is really 2.1 repeating, okay? All right, there you go, guys. Good luck tonight. Bye.